Hi, in this video, you will be learning more about the nature of mathematics and how mathematics can affect our world. According to Hoffman, Lockwood, Nation, and Clegg, on a book published in 2018, mathematics helps organize patterns and regularities in the world. Mathematics helps predict the behavior of nature and phenomena in the world, as well as helps humans exert control over occurrences in the world for the advancement of our civilization. Mathematics for organization. Mathematical tools to help us make sound analysis and better decisions. For instance, a particular store can gather data on the shopping habits of its customers and make necessary adjustments to help drive sales. Scientists can plot bird migration routes to help conserve the endangered animal populations. Social media analysts can crunch all online postings using software to gauge the netizen sentiments on particular issues or personalities. To put it simpler, mathematics can actually help business owners, scientists, or even people who are working on social media on how to create surveys or other things that can help them in their field of work. Mathematics for prediction. Mathematical models using existing data to generate analysis and interpretations can also be used to make predictions. Applying the concept of probability, experts can calculate the chance of an event occurring. The weather is a prime example. Based on historical patterns, meteorologists can make forecasts to help us prepare for our day-to-day activities. They can also warn us of weather disturbances that can affect our activities for weeks or months. Mathematics for control. Patterns are definitely present in the universe as demonstrated by means of examples around us. There seems to be an underlying mathematical structure in the way that natural objects and phenomena behave. These observations of nature, as well as their interactions and relationships, could be more elegantly described by means of mathematical equations. As stated by astrophysicist Brian Grease, with a few symbols on a page, you can describe a wealth of physical phenomena. Mathematics also shows control on the following things. Photographers could capture a single moment through a snapshot, and videographers could record events as they unfold. Definitely, mathematics has given way to the creation of technological advances such as the creation of cameras that photographers and videographers are using nowadays. Painters and sculptors could create masterpieces in interpreting their surroundings. Poets could use beautiful words to describe objects, and musicians could capture and reproduce sounds that they hear. As you can see, mathematics does not affect mathematicians alone, but as well as artists. Who else could prove the idea that mathematics shows control than mathematicians? One instance is in 1916 when Albert Einstein hypothesized the existence of gravitational waves based on his theory of general relativity. This is when ripples are formed in the fabric of space-time due to the large and violent cosmic events, very much like when a pebble is thrown on a stagnant pond. This time, we will be able to see how patterns and numbers in nature and the world are being affected by the concept of mathematics. Patterns in nature are visible regularities of form found in the natural world and can also be seen in the universe. Nature patterns which are not just to be admired, they are vital clues to the rules that govern natural processes. Here are some examples of these patterns, and you may be able to spot a few the next time you go for a walk. Have you ever experienced staring at the night sky, just looking at the wonderful cluster of stars that are shining bright on a lonely night? Patterns can be observed even in stars which move in circles across the sky each day. You can see that some stars are grouping themselves, and you can actually create some shapes, animals, or other figures out of the groupings of the stars. These are called constellations. The weather season cycle each year. All snowflakes contain six-fold symmetry, which no two are exactly the same. It's just that it's a very sad thing for us in the Philippines because we only have two seasons and we do not experience winter. Hence, we do not experience snowing at all. Did you know that patterns can also be seen in animals? Patterns can be seen in fish patterns like in angelfish, blue-spotted stingray, and whale shark. These animals and fish stripes and spots attest to mathematical regularities in biological growth and form. So, patterns doesn't only appear on non-living things but on living things as well, just like what can be seen on the patterns in these animals in the figures. As you can see, there are six other examples of fishes that have patterns in them. These are the spotted Murray eel, the spotted trunkfish, the coral grouper, yellow fish, red lionfish, and the green spotted puffer. Patterns cannot only be seen on animals that live in water, but on animals that live on land as well. Some of the examples of it can be shown on the pictures. Zebras, tigers, cats, and snakes are covered in patterns of stripes. Leopards and hyenas are covered in pattern of spots, and giraffes are covered in pattern of blotches. Now, how can we differentiate stripes, spots, and blotches? As you can see, stripes can be seen in shapes like this. Spots are just like huge dots that covers the body of an animal, while blotches are huge patterns like this. Like what I have said earlier, patterns in nature cannot only be seen on living things, but on non-living things as well. Natural patterns like the intricate waves across the oceans, the sand dunes on deserts, formation of typhoon, and water drop with ripple. This serves as clues to the rules that govern the flow of water, sand, and air. The intricate waves, the sand dunes on deserts, the formation of a typhoon, and the creation of a ripple from a water drop. Other patterns in nature can also be seen on different formations created by living things. This can be seen on the ball of mackerel, the V formation of geese, and the tornado formation of the starlings. Now, why do you think does these animals form formations like this? At this moment, we'll be discussing the different types of patterns and regularities in nature. Mathematics is all around us. As we discover more about our environment, we can mathematically describe nature. The beauty of a flower, the majestic tree, even the rock formation exhibits nature's sense of symmetry. Have you ever thought about how nature likes to arrange itself in patterns in order to act efficiently? Nothing in nature happens without a reason. All of these patterns have an important reason to exist, and they also happen to be beautiful to watch. These are the different types of patterns in nature. The first one is called symmetry. It is a sense of harmonious and beautiful proportion of balance, or an object is invariant to any various transformations. This can be seen on reflection, rotation, or scaling. The first type of symmetry is called the bilateral symmetry. It is a symmetry in which the left and the right sides of an organism can be divided into approximately mirror image of each other along the midline. Symmetry exists in living things such as in insects, animals, plants, flowers, and others. Animals have mainly bilateral or vertical symmetry, even leaves of plants and some flowers such as orchid. Take note, The other term for bilateral symmetry is vertical symmetry, and mostly it can be observed on living things. Here are good examples of bilateral symmetry. The first one is on the ipil-ipil, or in English, the river tamarind plant, which has a scientific name of Leucaena leucocephala. Here, you can see the midline of the plant with properly segmented left and right parts of the leaves. The second one is a Swiss Chinese plant, or more commonly known as the Monstera, with the scientific name of Monstera deliciosa. As you can see, its leaf has an equally segmented or almost equally segmented parts on the left and the right. The third example is a monarch butterfly with the scientific name of Danaus plexippus. As you can see, along the body of the butterfly, you can see its beautiful wings, which have a wonderfully equal, and its part of the wings have the same patterns if you're just going to observe. And the fourth example is a dragonfly, which came from the family of Anisoptera. Again, along the midline or the body of the dragonfly, you can see that its set of wings on the left and the right part are almost the same, or maybe they're approximately equal. The second type of symmetry is called the radial or the rotational symmetry. It is a type of symmetry which has a fixed point known as the center, and it can be classified as either cyclic or dihedral. Plants often have radial or rotational symmetry, as do flowers and some group of animals. Here are some examples of living things that can be classified as having a radial or rotational symmetry. One example of it is a starfish, which shows a five-fold symmetry that is common among echinoderms. The starfish is classified as dihedral D5 symmetry. The next one is for the sea urchins, or more locally known as tuyum. And finally, we have the sea lilies. Other sea organisms that can show radial or rotational symmetry are the sea anemones, whose adults do not move, and the jellyfish. In this case, a jellyfish is classified as dihedral or D4 symmetry. Be careful with jellyfish when you are swimming. Some of them can be very poisonous and it can be fatal. And finally, radial symmetry is also evident in different kinds of flowers, and we have five examples. The first one is the bee orchid. It is called such because the face of this orchid looks like a bee. It is considered as one reflectional and zero rotational. Why? One reflectional because it can only be shown in one particular positioning, and you cannot see any other face of this when you're going to rotate. That's why it's zero rotational. The next one is the yellow flag. It is three reflectional and three rotational. Why? Because it has three main bodies. If you're going to rotate this one thrice, then you can see three different reflections. The next one is the cuckoo flower. It is two reflectional and four rotational. If you're going to rotate this one four times, because of its four petals, then it can show you the same face of a flower. Two reflectional because the the face view, and then if you're going to flip this one backwards, then that's the second reflection. And we have the greater stitchworth. It has five petals, so it is five reflectional and five rotational. And we have the wild garlic. It is three reflectional and six rotational. Six rotational because it has six petals. Three reflectional, it's because the petals of it has pairings. It has two pairings, and because of two pairings, it reflects three different ways. The next type of patterns in nature are called the fractals. The fractals are curved and geometric figures, each part of which have the same statistical character as a whole. A fractal is a never-ending pattern found in nature. Take note, it's never-ending. The exact same shape is replicated in the process called self-similarity. The pattern repeats itself over and over again at different scales. Some of the natural phenomena wherein you can observe the patterns in nature known as fractals are a tree that grows by repetitive branching, the lightning bolts that you can observe in the night sky whenever there are thunderstorms, and the veins and other blood vessels in your body. Other examples of fractals can be observed in a single fern, wherein you can see its leaves curling, and even the aerial view of an entire river system, where you can see many outlets of rivers cascading on different paths. And finally, the third and the last type of patterns in nature are called the spirals. A logarithmic spiral or growth spiral is a self-similar spiral curve which often appears in nature. It was first described by the French mathematician René Descartes and was later investigated by Jacob Bernoulli. A spiral is a curved pattern that focuses on the center point and a series of circular shapes that revolve around it. Here are some examples of spirals that can be observed in nature. These are the pine cones, the grooves that can be seen on the body of a pineapple, the shell of a snail, and the whirlpools that can be created on the oceans. Spirals can also be observed in many plants. The reason for why plants use a spiral form is because they are constantly trying to grow but stay secure. Take note that there are many examples of spirals that can be seen anywhere, but only those that are created naturally can be considered as spirals in nature. Spirals such as the mosquito coil, the spring in mechanical motors are spirals but cannot be considered as spirals in nature. Thank you very much for watching. I hope that you learned something about the different patterns and regularities in nature.